Hi guys, this is Rahul from Finance Excel. Today we will be discussing the shape of the binomial distribution. This is one topic which has not been dealt in detail in our CFA and FRM syllabus. So I thought that I should do a short video on this topic. When I'm doing this video, I presume that you know a little bit of the basics of the binomial distribution. But if you don't worry. I'm going to give you a quick recap of it. Right. So a binomial distribution is a discrete distribution where there are only two possible outcomes, right? Their two possible outcomes are success or failure, and the binomial distribution can be used to measure the probability of X successes in n trials. Now we will discuss the properties of the binomial distribution. There can be only two possible outcomes, either a success or a failure. The probability of success and failure for each trial is the same. The probability of success is denoted by P, and the probability of failure is denoted by Q, which equals 1 minus P, right? And the trials are independent of each other, right? Now I will take up a problem set where we can apply the binomial distribution, right? The problem set is that when a six-sided dice is rolled thrice, what is the probability of getting exactly two fours, right? Now let us see whether the above problem set qualifies for the use of the binomial distribution, right? So by looking at the problem set, we can say that yes, there are only two possible outcomes. The first outcome is getting a 4, which is a success, and the second outcome is not getting a 4, which is a failure, right? Now the probability of success is getting a 4, right? So the probability of getting a 4 on a roll of a six-sided dice is 1 by 6. So probability of success is 1 by 6, and this is going to be the same for all the three trials, right? The probability of success won't change, right? And the probability of failure is 1 minus the probability of success, which is 1 minus 1 by 6 or 5 by 6. Again, the probability of failure also won't change, right? It would be the same for all the trials. Last but not the least, the trials are independent in the sense that the outcome of the first trial will have no impact or no bearing on the outcome of the second trial. So we can say that with this problem set, we can apply the binomial distribution, and we can use the following formula here to calculate the probability of exactly two successes, right? We can use the following formula here to calculate the probability of exactly two successes, right? So more about this formula in some other video, but today we are discussing the shape of the binomial distribution. Again, the mean of the binomial distribution is n into p, where n is the number of trials and p is the probability of success, right? How to derive this formula and what is the intuition behind the mean, we will discuss in some other video. This video is strictly about the shape of the binomial distribution, right guys? So now we know that the shape of the normal distribution is symmetrical, right? The mean divides the normal distribution into two equal halves, right? That is 50% of the area of the normal distribution is to the right and 50% is to the left. Again, the shape of the log normal distribution is skewed. That is, the log normal distribution is bounded by 0 and it is skewed to the right. But we know nothing about the shape of the binomial distribution. Right, guys? So we can see that, let us take a small example here, guys. Say there are six trials, right? That is, my n is 6. Probability of success is 0.1. Probability of failure is zero point 0.9. Mean is Obviously, mean is what? Probability of success into number of trials, that is zero point 0.6. Right. So, guys, now I have drawing up the probability mass function of the binomial distribution, and I am plotting it on this. I am plotting this on the histogram here. Right, guys. Now you see when the probability of success is zero point 0.1, right? The binomial distribution is positively skewed, right? It is positively skewed. We can understand this, guys, right? Because of the long right tail, right? We can also say that it is right skewed or positively skewed. When the probability of success is 0.2, again it is positively skewed or right skewed. When the probability of success is 0.3, again it is somewhat right skewed. Right, zero point 0.4. Right now the skewness is decreasing. The skewness is decreasing when the probability of success is zero point 0.5. Guys, see, when the probability of success is 0.5, the binomial distribution is symmetrical. Right, the mean of the binomial distribution is 3. Right, the mean of the binomial distribution is 3. Right, and we can see that there are equal probabilities on the either side of the mean. Right, we are seeing equal probabilities on either side of the mean. Right, so mean of the probability of having 0 successes is equal to the probability of having 6 successes. The probability of having 1 success is equal to the probability of getting 5 successes. The probability of having 2 successes is equal to the probability of having 4 successes. So we can see that there are equal probabilities on either side of the mean, confirming that it is perfectly symmetrical, right? Because we are having equal probabilities on either side of the mean, right? Okay, so guys, this is about the binomial distribution, right? When I increase the probability of success to zero point 0.6, again we can see that it is starting to become negatively skewed or left skewed. 0.7, again we can see it's left skewed. 9, when the probability is 0.8, we can see that the skewness is increasing, and the negative skewness is increasing, right? Right, guys, so we can see that the binomial distribution is skewed, is symmetrical when probability of success is 0.5 and is skewed for any other probability of, right, guys. So this is about it, about the shape of the binomial distribution. Hope you liked the video.